Um, so let's start. Last week I was still working on the B plus tree implementation, but it turned out when
On
I
what,
come
sorry?
across, oh,
What did you say? On what were
oh,
you working?
oh, I was still working on B plus tree implementation, but it turns out we have already an implementation in our source tree already. It's located in slash included slash CPP B tree, and it's in a pretty good shape. What is missing is that we just need to separate out the allocator and deallocator and the mutator, so so we can plug into our data machinery into it. So we can write an ADL a record when it's tried to mutate for example, an internal node, or call out to the allocator when it's need to split an for example, a leaf code into two of them. So I'm looking into that P-tree. The first step is to modernize it by using some C++ 17 technique to replace some of its own homebrew replacements, and then to generalize it so we can use it for SeaStor. And also
Is there, sorry, Kifo, is there any other source of which is already modernized for B-tree source?
mm, actually I've been looking into 3 implementations, and I don't think there's some modernized between implementation regarding to the C++ 17.
Okay, thanks.
But I think the upside of this between implementation is that we are already using it. So if I clean it up, the classic OSD will be also benefit from it. I think that's why I try to use it. And
Who is using the B tree? Which part of Ceph component?
I think we are using it for our. Hold on, let's see. I think BlueStore is already using it. Hold on.
Mm.
B-tree. And let's see, and MDS also. So I'm still looking into Ronan's PR to bring the ASOC support to Crimson. And
Okay, good.
I think it's a very large change to, I mean, a large addition to Crimson source tree. One thing I coming into my mind is that we actually have a very large refractory in this area in classical OSD actually, which try to unify the tail commands and ASOC. So the tail command can hit right to the specified OSD by passing the signified command map. Let's put it this way. And the same applies to the ASOC approach. So I'm trying to figure out how we can have this part built into Crimson as well, because ideally we need to be compatible with classical OSD, and I think it's a very useful feature because one is able to pass a standard command to a given OSD without the need to talk to the underlying ASOC, right? Very useful.
I actually, even before I noticed it happened in standard, in classic OSD,
Yeah.
I was starting to combine the command interface to use the same mechanism. Now that after that I saw that was already done in the classic OSD, and I would suggest to accept this PR and then move the command interface to use the same mechanism and try to combine it to push it or to merge it somehow with the classic OSD. I'm not sure it's possible because there's a lot of SeaStor code, SeaStor way of coding there, but maybe copy, like I started to do, copy the idea of translating everything into these commands, both from
I guess that'll be a last resort.
Yeah. So yes, it's obvious that both interfaces are very similar and they are doing similar things.
Indeed.
And I would do it. I plan to do it stepwise. That's the main. That was my main idea.
Yeah, probably we don't need to do two steps in a single PR, but I think we need to take that into consideration when we ship out the we ship the interface, because
Yes.
it's the interface that matters. Aside from it, I will be on vacation. Actually, I'm on PTO this week, so that's the plan. Ronan.
Well, I had a problem. If you saw one of the new comments I had in the new version of the PR, I had a problem when trying to abort the OSD, when trying to use, for example, SIGINT on the OSD and get it to terminate. Something wasn't working right. I tracked it. What I did this week was to track it down to mishandling of accept abort by SeaStor, at least when EPOL is used. And I think I now have a fix for that. I'm testing it to make sure that I didn't ruin anything else. It boils down to more or less one line change in SeaStor. Now, hopefully it will pass test today, and I'll make sure that I'm not ruining any other test by SeaStor, and then I can push it to our own SeaStor. I'm not sure it will make sense to push it to the DB SeaStor upstream, because they have changed the whole area. They have made the large changes to the whole in new versions to the socket implementation. So I'm going to check this if it makes sense to push it. If not, will be a local change for an old version of SeaStor for us.
The real change is not compatible with the overhaul to ASOC implementation in upstream CDB.
I think it's not. I'm not sure yet that if it is compatible or not. What Avi did is redo the Unix domain sockets and every other socket, and unifying the handling the way I didn't want to do originally. So the code is now changed in a major way. Maybe it's still. I'll test it. I'll check if my change is still applicable. If so, I'll try to push it. If not, it will be a local change. what happens
I would
is
prefer avoid such kind of logo change on top of a old branch of a CDDB SeaStor. Otherwise, we need to have our fork. We have some local commit, but that's not related to the core code of a CDDB or SeaStor. It's only related to how we handle the, for example, the address sanitizer change in the CMake script, but we don't touch the .h or .cc in CDDB. So I would suggest we avoid such kind of local change. That will be the start of fork of a CDDB. That's something we.
No, of course not. I'm not trying to fork because the only reason it will be local it will be because they already fixed it in because they changed everything. Already fixed it in.
That is even better. So we can just pick up the latest CDDB, so the problem will go away. Is that what I mean?
Yes, but then we'll have to pick up a whole a larger change. Maybe it's a good idea. I don't
on ASOC, right?
Yes, maybe it's not a good. I'm not sure it's a bad idea, but it's a larger change.
I see. Okay.
They made improvement to many areas. Some of it because what Radek and others pushed. So it might be a good idea to take a newer version of SeaStor at some point.
So, but I think we are already picking up the latest SeaStor, a very recent SeaStor commit recently. So you will have to adapt to it. That's my guess, actually. You might want to check out our SeaStor submodule commit. Probably you will have to up to the PR to adapt that change.
Okay, maybe I'm a bit. I'm based from before I started to work on the.
Yes.
Yeah.
That's my guess.
I have to check that
because since Redux, some of Redux proposed change had been merged by the upstream, we bump up the SeaStor submodule like just 1 week ago. So that might already include the obvious unified over how to using domain sockets.
So yeah, probably it will. Good. Okay. Thanks. I check that. And apart from that, I'm looking for things to do in our work on SeaStor. I appreciate guidance in where I can help with SeaStor.
Okay, probably we can do it in. We can split conquer the SeaStor and after the vacation. Good. Meanwhile, I think what we can do is to read James' design doc and to solidify some of the losing end.
Okay.
And Xuehan, is there anything you want to share with us?
Can you hear me?
Clear and loud. Yes, I can.
Can you hear me?
Yes, I can.
Yeah. For the last 2 weeks, I was trying to catch up with you guys, and read the papers of the ButterFS and App2FS, and I also investigated the Intel DAOS system, which is DAOS, distributed synchronous object storage. What I'm doing now is I'm trying to investigate the data structure of R-tree, which Intel DAOS used to index its extents. I think the advantage of it is it could provide a more efficient snapshot lookup and creation. But whether it is really more efficient, it just needs more work, and that's pretty much for me.
Do we need snapshot support in the OSD level?
I think so. SeaStor needs, like BlueStor, SeaStor also needs shared extents or blobs, right?
I think so.
Yeah, because if we do snapshot, we need to share the same content to different objects, and if we want to, it's like a basic functionality of a snapshot. And if we want to modify it, we need to copy it, then copy it.
Right.
Do right, yeah.
I think the Intel DAO system also involves HLC, which is hybrid logical clock. Should also provide some very efficient snapshot creation operations. I'm also looking into that.
So which tree is DAOs using? I'm missing the.
Not trees. It's epoch. It's an epoch. Yeah, I can. Is this HLC? Should hybrid logical clocks.
Yeah. You mentioned before DAOs is using a tree to do
like
snapshot.
R tree or something.
R tree.
R tree. Okay.
Basically, this data structure is used to index spatial data, such as the geographical coordinates or polygons, something like that. But Intel DAO system used it to index its extents. So I think maybe it's worth some investigation.
So you're talking about how the allocator utilize the
no, I wasn't. I think the R tree may be useful to index extents of some O node or some objects, because in our production environment we kind of most time we kind of hope that we can use a relatively big object to store data. For example, a 10 gigabytes size object, which means the object number is relatively small, and we can keep all the object metadata in the OSD memory to avoid extra I/O operation when doing data read and write. So if an object is relatively large, then it may involve many extents. So and when we are doing snapshots, then we kind of should need some efficient way to manage those snapshots. So I'm trying to find some efficient way for snapshot creation and snapshot lookups. Basically we are still trying to find a way to implement efficient backup or replication at the RAIDers level. We think that although Ceph Array has mechanisms like RBD mirroring or RGW multisite, but if we can do replication at the level of Raiders, we think that it should be more efficient since it can avoid extra data write operations. We do not have to keep 2 copies of a journal. I don't know if I'm making myself clear.
So, Jehan, if I understand correctly, you are talking about the replication between two hosts, right? Instead of the snapshot
two clusters.
machinery.
2 clusters.
Okay. So to be honest, I don't think it's related to SeaStor. Am I right?
Sorry, I didn't. Could you repeat that?
Sure. So if I understand correctly, it's not related to SeaStor. It's more related to how a Civ cluster replicates the write operation between 2 clusters.
Yeah, but I think that we are considering implementing that replication mechanism on SeaStor, and because if we implement that mechanism on BlueStor or some the older one FileStor, that's just not very useful to us, because in the future we will be using SeaStor. So, although this replication mechanism work should be started after we have a really working SeaStor implementation, but we just think maybe when developing SeaStor we can do some preparation. I don't know if it's like efficient. We think that an efficient Raiders level replication mechanism relies on some SeaStor's inner mechanism. If
you mean
SeaStor
we might want to? Okay, go on. Sorry.
We think that if the SeaStor is not considering implementing a Raiders level replication mechanism inside it, then if the SeaStor does not take that into consideration, then after the implementation of SeaStor, we may find it hard to implement an efficient replication mechanism on top of it. So we think that, for example, if we can implement a much more efficient snapshot management code, and then that should be useful to an efficient replication mechanism.
Yes, actually, I'd like to understand how that could impact the implementation of SeaStor. In what way? What I can think of is that the journaling in SeaStor might help, but I'm not sure.
I think that for example, if we can implement a snapshot creation operation that takes almost nothing overhead, then when doing cluster level Raiders level replication, we can just create snapshots at any rate that we want, and back up those snapshot differences to another cluster. But if the snapshot creation operation itself will involve much overhead, then we cannot take a very efficient. We cannot make a very efficient. We cannot make a very high rate of snapshot creation, which means the interval between snapshots may be too long, and when disaster happens, we may lose more data. That's our thought.
Yes, I understand the use case of a finer grain snapshot, which means we can have less loss when some bad happens. But that's basically a requirement instead of regarding to how we gonna to address that kind of a requirement and how it's related to SeaStor design at this phase.
That's exactly what I'm trying to make clear now.
Okay. Looking forward to your potential approach to address this problem, and we're hearing. Thanks, Shannon.
Yeah.
And
thank you.
Hello, can you hear me?
Yes.
Seems my network is slow. I'm not sure if you can hear me. Okay, so last week I'm looking at the F2F paper and the zone devices specifications, and it seems that FTL as SSD with FTL and the zoned SSD have very different behaviors. So I have some doubt about whether these optimizations still works well with FTL SSD and zone, because basically most of the SeaStor optimizations is targeted the zone SSD. So I'm not sure if it works well with FTL FSDs. For example, like multi-head journaling. I just saw from the discussions that it will transform to random writes with FTL SSD, and maybe it will not show much benefit with it. And I also looked at SPDK specification that if we as SPDK can control the hardware level queue for NVMe SSDs. So I think maybe that means that if we want to have those optimizations, we might need more control of the underlying NVMe devices.
Yeah, I agree with you. If we want to make better use of the underlying hardware queue, we need to use, instead of using the underlying NVMe device as a block device, we need to use some low-level primitives to take better advantage of the hardware queue. Regarding to the multiple journaling, yes, I also agree with you that if we will be using multiple journaling, it will be translated to random write in a FTL-enabled SSD. In that case, I think we will be degraded to a single journaling and let the FTL do its job.
Yeah, unless we have more control of the queues of the NVMe SSDs.
But I don't think that's closely related. One thing is to hardware level parallelization. Another is to use different zones for separate the I/O with different life cycles. I think they're close, they're related, but not the same thing.
Yeah, but we are trying to do those two things with with the
multiple
segments, right? We want segments to separate our data to SSDs, and also want to write two separate segments to enhance the parallelism, right?
Yes.
And we don't have control over SSDs that have FTLs. We might not get such good things with those SSDs. But that's only my doubt. I think we still need to make more experiments.
I think in the case of ZNS devices, we will be able to take advantage of the hardware level parallelism.
Yeah, but zone,
when we are be able to write different zones.
But ZNS is still not yet published, right? So do we have such device already?
I think they are sending some samples to our lab per SEM. They mentioned this the other day, but I think there are some emulators on GitHub that we can be using before if we don't have such kind of sampling in our hands.
Mm-hmm.
So if we wanted to experiment on some real-world devices like some FTL enabled SSD, I think a single journal will also help if we using the same journaling machinery we are looking at when designing SeaStor. If we don't use multiple journaling, that would be help also. That would be help with the SD. Even they have FTL. The FTL don't need to translate the writes into rhythm writes. If we only use a single journaling. That's my guess.
Okay. So the second, I'm looking at the issue of ASN. I just run the unit test, messenger unit test, since it doesn't happen with the unit test. So maybe I will need to start a vstart cluster and try to. I guess that's happened when we stop a cluster, right? It's writing to a closed or a freed socket, right? So OSD is writing to a closed socket or a freed socket.
You're talking about
so that's why.
the test failure I sent it to you.
Yeah.
I think it only happens when we are testing the unit test of a SeaStor socket.
Unit test, but I just run this several times. I didn't see any errors from ASN. Is it just happen very rare or very frequently each time?
It's not very reproducible, to my understanding.
Okay.
It happened like 1 out of 10 times or so.
Let me try to reproduce first.
Yeah, thank you. And any questions? Okay, I think we won't have the we will skip the next stand up next week, and we'll continue on with stand up next year. So
next decade.
And, thank you. Next decade. Oh yes, true.
See
you next decade.
See you. Bye.
See you. Thank you.